Recording. What I'm going to do is I'm going to share my screen. I'm going to go through the solution to the lab, and I'm going to record that for the other students. And then I'm going to stop recording, and then I'm going to answer each of your questions so that you can submit the lab. Does that sound like a plan? Okay, here we go. Now let me walk through this lab, and hopefully everyone can see the Excel sheet in front of you. Can you? Hi, Derek. How are you? Okay, here we
Good.
go.
How are you doing?
Very well. So we've gotten to the point in the course where you have created multiple models. Well, I've given you the models. You've inputted the data, and you've outputted the analysis, and you've hopefully made some decisions. So now we get to the point where we use probably the most sophisticated and complex tool that Excel offers, and that's called Solver. And Solver is a tool that allows you to optimize or minimize problems in business. Solver is used extensively in human resources and production planning. For instance, if you're running a factory and you have a variance in orders on each shift, obviously it's really important that you have the number of employees there to produce on that shift, but you don't want a lot of people there that you don't need, nor do you want to have too little staff and you can't meet production. So that's another example where Solver is used. And as you continue your studies, here we go, there's some more people coming in. As you continue your studies, I think this is going to be a really useful tool. So anyway, here's the setup. So this is not a math problem. This is really a logic problem. So let's begin. So what I do, the first thing I do when I have a problem like this is, for me, this is very difficult to understand. So what I do is I go up and I set up a chart that helps me visually understand what's going on. So we have two variables, and the variables really are the number of juice cases that we can produce in a week and the number of wine cases that we can produce in the week. The word problem tells us that in our factory, we have storage space, and our maximum storage space is 60,000 square feet in our warehouse. The storage space for each case of juice takes up 12 cubic feet, or a pallet, I guess you wouldn't really think of it that way. And a wine case would take up about 18 cubic feet of storage space. The production rate, I've been offering this lab for years, and this is always the number one problem with most students is understanding the production rate. And I give it to you here. The production rate, we need to solve for hours per case. And the reason we need to solve for hours per case is when we put it in our model, we want to take the optimum number of cases that would be produced for juice and wine. So we take that optimum number and multiply it by how many cases can be produced in 1 hour. Because overall, the machine is only available for 60 hours of production a week. So this goes back to high school algebra. And when you think about it, I think you'll say, oh, okay, I get it. It really wasn't that complex. So if it takes 6 hours to make 100 juice cases, how many hours X does it take to make one juice case? Well, you do your cross multiplication here, 6 equals 100X, you solve for X, and it's 6 hours to make one juice case. So that is the basic algebra formula where you determine how long it takes to make per one case. We have another marketing constraint, which is we can only sell 800 juice classes. So we can't make any more. We can make 800. But if we make more than 800, our marketing department says we can't sell. And our profit is $12 per case for juice and $9 per case for wines. Now, I found an error in my instructions. I put in $10 and $7. $10 profit for juice, $7 for wine. Those are the numbers I used in the fall semester. I changed them for the spring semester. I didn't change it everywhere. So I get that. That's something that I need to update. So you can solve for either $12 and $9 or $10 and $7. That's fine. I will give you credit. So, but anyway, let's go ahead. So this is the problem right here. This takes all of these words and translates it to something that I understand and something that Excel is going to better understand. Now, so we have two variables, juice cases and wine cases, and we have three constraints. We have a warehousing constraint, we have a marketing constraint, and a production constraint. And you know, this is a very practical problem. Any of you who work in manufacturing, you know that's very typical. Those are constraints that do exist, plus many, many more. So where do we begin? So second of all, we identify our three constraints. Then we set up the logical constraints. In fact, I'm going to go over here and type in the word logical. Now, these logical constraints, you and I as humans understand, but Excel doesn't understand. So the first one is the warehouse. So again, the number of optimum cases times 12 cubic feet plus 18 cubic feet times the number of wine cases must obviously be equal to or less than 60,000. If we go over that, we're putting glasses in the parking lot. That won't work. So that is a constraint. It's a physical constraint. Marketing, I think this is the easiest one to understand. Marketing says that the number of juice cases has to be less than, or actually it would be less than or equal to 800. And our production, I already explained this, where the 0.06 and 0.05, those come from cases per hour. And then finally, we set up our maximization formula. And as you can see up here, I use $12 and $9. As I said, you can use 10 and 7. It makes no difference. I'll give you credit. So I take $12 times the C2, which is the maximum number of juice cases that can be produced, and $9 times the number of wine. So let's look at this. These two cells up here, I have not put anything in. I've identified these cells in my formula, but Excel is going to use Solver, and Solver is actually going to put the numbers in there. So leave those cells blank. Solver will do the work for you. Here on these output cells, again, what I have done is I have taken this logical constraint and I have translated it into a formula that Excel understands. In this case, 12, which is D2, or you could type in 12 if you wish, times C2, the number of glasses and juice, plus storage space for wine, times, where am I here? Again, times the optimal number that Excel is going to put into that formula. So let me go over that again, just to make sure. And again, what I did here, so in this constraint, I identified where Excel is going to put the optimal production of cases per week. And then I multiplied it by the numbers of storage space that were given over here from the word problem. Okay. The next one is really easy. Again, it's just juice cases has to be less than or equal to 800. So I simply said equals C2. So what's C2? C2 is where Excel is going to put in the optimal number of juice cases that will be produced in our model. And finally, right down here, production. Again, production cannot exceed 60 hours. I take this logical statement and I plug in the values. Again, C2 and C3 are values that Excel is going to give me, Solver is going to give me, And then I also plug in my case rate per hour. So these are the three logical statements. These are the three statements that I created that translated the logical statements into statements that Excel could understand. Again, this problem is a logical problem. It is not a really a high math problem, as you can see. When I was in grad school, we had to do this with pencil and paper and use multiple linear equations, and it was painful, to say the least. I still remember using that. Now we have these great tools that you can use in Excel that will allow you to set up these very complex models, these optimization models, using a tool called Solver. So where do we go from here? So the next step that we do is we go up to Data, and we go over here in Solver. Now, this is really important. So now that you've set up your model and where all of the data is going to appear or does appear, next you have to tell Solver, okay, let me know what's going on. So first of all, set objective cell. The set objective cell is, what is the maximum amount of money that we can make in this factory given these three parameters? So where is that formula? Right down here, C15. By changing variable cells, well, we have two variables. We have juice and wine, and those variable cells are C3 and C2. And what I did here is I dropped and dragged those. I didn't type that in. I love drop and drag in Excel. It saves me from typing. And then I have to add the three constraints. Now, what I have to do here, again, you need to translate these logical constraints over here to constraints that Excel will understand. So let's look at that. Let's look at this one. And you add each one by clicking add, but I've already done that. So let's take a look at this. And let me see, what's the best way that I can look at that without. Solver sometimes is very temperamental. So let's do edit. Let's do change. So when this pops up, I put the cell reference. So where is the answer going to be? That's the cell reference. So the answer for the warehousing constraint is going to be in C11. And what is the Boolean operator? Boolean operator greater than, less than. Remember that from algebra? So you can select ours are less than or equal to, and the constraint is 60,000 feet. You can add that. I'll just click OK. We'll go into the second one here. We'll look at the data that I put in. And here it's C12. It has to be less than or equal to 800. Looks good to me. Okay. And finally, the last one, let's look at this one. So C13, which is production, has to be less than or equal to 60 hours. So that really looks good. Now, as I pointed out, please make sure that these are non-negative numbers. If you were doing a minimizing formula, they could be negative. But in this case, we can't make a negative amount of glasses or have a negative amount of storage space or negative production space. That doesn't work in our universe. So make sure that's non-negative and use simplex. Now you have other opportunities here. In fact, you could do very complex nonlinear evaluation, but in this class, we're not going to get into that. So just make sure this is checked here, unconstrained variables, simplex, click solve. And when you click solve, and again, many times if you click solve multiple times, you're going to get an error. Sometimes Solver does get a little confused. It solved the problem, and then you ask it to solve again. So I'm not going to do that. So when I clicked OK, this is what happened. And here are the answers. Excel went out, Solver went out and put in what is the maximum number of juice cases that can be produced per week given all three constraints, 800. That's the answer. Number of wine cases, 240. Okay, so those are the maximum number of warehousing, marketing, and production cases that can be produced. under those constraints. So what would the output actually look like? Well, outlook would actually look like we're only using 14,000 square feet of our 60,000 square foot warehouse. And you say, well, why don't I fill it up? Let's fill the warehouse up. Well, you can't fill it up because you have marketing and production constraints that will not allow you to fill it up. Here at marketing, the formula said, okay, we're going to sell all the marketing. We're going to let marketing sell all the juice cases we can for 800. So that maxed out at 800. And we're going to run that machine a total of 60 hours through the week, producing all of the glasses we possibly can do. So while we maximize production, maximize marketing, you can see that our warehouse space is not maximized. But again, we have to be attentive to all three constraints. The answer is, again, then we go down here, given these constraints in our factory, the maximum revenue, the maximum sales revenue that we can bring in is $11,760. Now, let me just say one more thing about the practicality of why you're learning this in information systems. You're learning this because I want you to leave this course understanding that you can use data and information to create knowledge, and that knowledge is so important. For instance, if you owned this factory and you needed to expand, or you needed to buy a new machine, or you need a loan, you would go to the bank and you'd sit in front of the loan officer and say, listen, I need a loan. Can you give me the loan? And the officer will say to you, well, tell me about your business. Are you making money? What is the maximum profit that you can make out of your business to pay back the loan? And if you went to Penn State and you took this course as a business student, you can say, I'm glad you asked that question, because here is my optimization formula showing the bank that I can maximize $11,760 profit if under these constraints. And if you give me more money, maybe I can buy a new machine that will up production from 60 hours to maybe 80, 90, or 100 hours. And we can then go back and rerun the formula, and that's what will happen. Now, I'm going to go up here, and I'm going to stop recording.